Let's do example 4. Find zeros of this polynomial. Start with rational zero theorem. Check A naught, which is -3. Its factors are plus minus 1 and plus minus 3. Check the leading coefficient, which is an is equal to 1. Its factors are plus minus 1. So, possible rational zeros are with numerator from here and denominator from here. So, plus minus 1 by 1 and plus minus 3 by 1. So, possible rational zeros are plus 1, -1, plus 3 and -3. Let's check in the calculator. So, I'm going to check from my calculator which one out of these 4 looks like the 0. I wrote it in my y. I'm going to graph it. So, seems like so if you see, neither 1, -1, 3 or -3 is looking like the 0 because the graph is not passing through any of these points. So that means all of these can be crossed. They are not, none of them are zeros because of the graph, right? So that means we have to find another way of solving this polynomial function. Let's write the polynomial function one more time. X raised to power 4 minus 2x square minus 3. If I replace x square by u, then this would look like u square minus 2u minus 3, which is just a quadratic function. So if I have to find zeros now, that means we have to find the zeros of u square minus 2u minus 3 equal to 0. What are the zeros of that? You can use the formula -b plus minus square root of b square minus 4ac by 2a. b is -2. So this plus minus square root -2 whole square. 4 times 1 times -3. Whole thing is divided by 2. So if you solve that, you will get 2 plus minus 4 plus 12 by 2. So we have 2 plus minus 16 by 2, which is 2 plus minus 4 by 2. That means u is 2 plus 4 by 2 or 2 minus 4 by 2. This is going to give you 6 by 2, which is 3. 2 minus 4 is -2 by 2, which is -1. Now, we were not supposed to find u. We were supposed to find x square. X square is u. So, x square is equal to u. U is either 3 or x square will be equal to -1 because that is the other option. So, from here we are getting here and from this we are getting here. So, x square is equal to 3. So, x would be equal to plus minus square root of 3. If x square is equal to -1, x is equal to plus minus square root of -1. Now, in real numbers, there is no value for square root of -1, but we define complex numbers. Square root of -1 is called iota. So, x is equal to plus minus iota. So, what are the zeros we have? X is equal to plus minus root 3 and plus minus iota, or we can say root 3, negative root 3, iota and negative iota. As you see, there is none of these numbers is a rational number. That's why from our rational list, none of the numbers from the calculator was becoming a zero of the function. Zeros of this function are root 3, negative root 3, iota and negative iota. Next we have fundamental theorem of algebra. It says if a polynomial function f of x is of degree more than 1 with complex coefficient, then f of x has at least one complex 0. That means if the function is polynomial of degree more than 1 and it has a complex coefficient, it should have at least one complex 0. Then we have linear factorization theorem that states that if f of x is a polynomial which looks like this and degree of the function is more than or equal to 1 and the leading coefficient is non-zero, then it can be written as an, which is the leading coefficient here, times x minus c1 times x minus c2 and so on x minus cn, where c1, c2, cn are the complex numbers and these will be what? c1, c2, c3 and so on. They will be zeros of the function. Okay. Next, if f of x is a polynomial of degree n more than or equal to 1 with complex coefficient, then f of x has exactly n complex zeros provided that each zero is counted by its multiplicity. So, how many total zeros a function can have? A polynomial function's number of zero is given by the degree of the polynomial. So, number of zeros of a polynomial function f of x is equal to degree of the function. Next, we have conjugate zero theorem. What is conjugate zero theorem? If f of x is a polynomial with the real coefficients and if a plus b iota is an example of a complex number. A plus b iota is a zero of f of x, then its conjugate a minus b iota will also be 0. If a plus b iota is a 0 of the function, then this will also be a 0 of the function. Okay, so we are saying if any function f of x, polynomial function, has one 0 which is a complex number, then for sure there will be another complex 0 which is the conjugate of that number. Okay, that can help us find a lot of other zeros and simplify our function. Let's see. We have a function f of x is equal to x raised to power 4 minus 6x cube plus 28x square minus 18x plus 75. 3 minus 4 iota is a 0. 3 minus 4 iota is a 0 of the given function. Then its conjugate. How do you write conjugate? Conjugate means just change the sign of the complex part. So 3 plus 4 iota. Its conjugate, which is 3 plus 4 iota, it will also be 0 of the function. Okay. Now we already have two zeros. The degree of the polynomial function is 4. So there will be total 4 zeros. Let's try. If 3 minus 4 iota is a 0, how can we find all the other remaining zeros? We already have 2. So we have to find 2 more. 3 minus 4 iota is a 0. Let's reduce the polynomial. Let's write the polynomial and divide it by the factor of coming from 3 minus 4 iota. So I'm going to write 3 minus 4 iota here and do the synthetic division. 1 goes down, multiply it by 3 minus 4 iota. When you add, only the real parts add. So negative 6 plus 3 is negative 3 minus 4 iota. 3 minus 4 iota times negative 3 minus 4. So multiply 3 minus 4 iota with negative 3 minus 4 iota. How do you do that? So you can distribute. It will be negative 9, negative 12 iota plus 12 iota plus 16 iota square. This cancels. Negative 9. Iota square is negative 1, so it is negative 25. So this number here is negative 25. Add, we will get 3. Multiply 3 minus 4 iota by 3 would be 9 minus 12 iota. Adding, we get negative 9 negative 12 iota. Again, we need to practice how to multiply 3 minus 4 iota with negative 9 minus 12 iota. We can distribute. So what do we have? This can cancel. Negative 27. 48 iota square is negative 1. This is 48. That would be negative 75. So we write that here. When we add, we get 0. We knew that, right? But now we have the quotient. So we can say the quotient is this with the degree of 3. So x cube plus negative 3 minus 4 iota x square plus 3x and this. Also, we know that 3 plus 4 iota is also a 0, right? So that means we should divide by the quotient by that x factor. So let's try 3 plus 4 iota, okay? That means we divide the quotient, which is having the coefficients like this, and you have to write 3 plus 4 iota here. Synthetic division we already know. 1 goes down, multiply 3 plus 4 iota, add, you get 0. This time this is 0, multiply, add, you get 3. Multiply 9 plus 12 iota. When you add, we get 0. So now the reduced polynomial will be of degree 2. So x square, x and constant. That means reduced polynomial left is x square plus 0 times x plus 3 equal to 0. And from there I can find the roots easily, zeros easily. X would be plus minus square root of negative 3. Now normally real numbers, square root of negative is not a real number, but we can define it as a complex number. Square root of negative 1 would be iota, square root of 3. So we have all the zeros. All zeros are 3 minus 4 iota, which was given. Then we said 3 plus 4 iota because it's conjugate, and we solved and found the reduced polynomial from here that gave us root 3 iota and negative root 3 iota. So we did the first part. We can do the second part, just writing the factors from the zeros. That will be easy. The factors come in the form of x minus c, right? The c is coming from here, the zeros. So that means f of x is equal to x minus 3 minus 4 iota, x minus 3 plus 4 iota, x minus root 3 iota, x minus minus, so that will be plus root 3 iota. And solving the function equation, this will just gives you all these roots.